Hey there, welcome back. Thanks for checking in. We are still working in Unit 5, and so far we have spent a few days solving systems of linear equations using graphing, right? So you would graph both lines on the same coordinate plane, and then you would look at your lines and kind of decide what is the solution for the system. Remember, there were 3 different things that could happen when you graphed your lines. Well, we are still solving systems of linear equations, but this is a new way to do it, and it does not involve graphing. It is called substitution, and I tried to warn you about this ahead of time. I tried to tell you that the next thing I was going to show you had nothing to do with graphing, and it had everything to do with algebra, so working with equations. Well, what in the world is substitution? Here's what it is. It's when you use one of the equations from the system. Remember, a system is 2 equations. So you're going to use one equation from that system, and you're going to plug it into the other equation in that system, and that's going to help you find the solution. So you're like, I have no idea what you just said, Glessner. That makes no sense to me. And this is one of those things, again, it's really hard to put into words. It's easier for me just to show you how to do it. So step 1 is when you look at both of your equations, you have to pick one of them, and hopefully there's one that has either been solved for one of the variables. So it might say something like this. It might already say like y is 3. Right? That could be a linear equation. So you're either going to look at your 2 equations and find the one that looks like that, so it's already been solved for one variable, or it's something that could easily be solved for one variable. So something like this, where you could then easily divide by 3 here and divide by 3 here, and then you would know then that y was 2. So this is step 1. Solve one equation for one of the variables. Sometimes that'll already be done for you, and sometimes you might have to do a little bit of work to solve for one variable. You'll see what I mean. It's not that bad. So by the end of step 1, you will know that either x equals something or y equals something. You need to know that in order to move on. Because in step 2, you'll take the solution from step 1 for whatever variable that you know the value of now, and you will plug it into the other equation in the system. So if you now know that x is 2, you're going to take that amount for x and substitute it into the next equation, and you'll be able to solve that equation for the other variable. Step 3 is substitute the value from step 2 into either equation and solve for the other variable. I don't know how else to describe this. I know you're probably super confused, and it's like I said, it's super confusing for me to try to explain it in words, but it's like you have to take one equation, substitute it into the other equation, and by the end of doing that maybe more than once, sometimes you have to do it twice, you'll end up with what the x value is equal to and what the y value is equal to. So by the end of this whole process, you will have that ordered pair. You will have that x and y value that will solve both equations, and you will be wishing that you were graphing these things like we already learned how to do, especially if you're at all a little forgetful and you've forgotten how to work with equations, because it has been a while. Let's just take a look at one, okay? Here we go. Solve using substitution. Here is the system right here. This is it. Those are my 2 equations, y equals 7 and y equals 8x minus 9. Those are 2 linear equations. So step 1 says pick one of the equations and solve for one variable. So do you see how the top one right here, where it already says y equals 7? That's what I'm talking about. Step 1 shouldn't be that much work. And in this case, step 1 is done for you. They're telling you half of the answer. They're telling you that y is equal to 7. So right off the bat, already, in your ordered pair that's going to become your final answer, they're giving you half of the answer. They're telling you y is 7. Okay, so step 2 says, take that information of y being 7 and substitute it into the other equation. So we take that 7 for y, and we put it right here. See? Put your eyeballs down here. So now it says 7 equals 8x minus 9. Now what variable is left? Like now who are we trying to decode, or who are we trying to solve for? We're trying to solve for x, right? We substituted in 7 for y right here. And now we have to do the math, solve the equation for y, or for x. X is grumpy, right? This guy right here. He wants to be alone. Remember doing this? Your job is to move the numbers away from that x. So you move the minus 9. You got to get rid of that minus 9 first. So you add 9 to both sides. So that'll cancel there. On the left side there, 7 plus 9 is 16. So now I have 16 equals 8x. X is still not alone. He doesn't want to be multiplied by 8. So you divide by 8 on both sides. That cancels that out. And 16 divided by 8 is 2. X is alone and he's happy. You solved for x. So we were told in the very beginning that y is equal to 7, and I told you that's half of your answer given to you. And then you just substituted in that value into the system and found the x value, and the x value is 2. So now you have your solution. That's the answer. 7 for the y, 2 for the x, that is your solution. And again, I mean, I hate to keep saying this over and over again, because sometimes I feel like I repeat myself so many times. What does that mean? What does that mean? That the solution is 2, 7. What that means is, if you put a 2 here and a 7 here, and you actually did the math, both sides would be equal to 7. Mathematically, it works. And it would work in the other equation as well, right? This equation right here. Yeah? Put the 2 here, put the 7 here, and it's going to be 7 equals 7. Mathematically, it works. You are finding the x and y value that works for both equations. Okay, let's do another one. This is a nice little system here. We have two equations, y equals 7x minus 10, and y equals negative 3. Step 1, solve for one of the variables. So in this case, again, they were super friendly, and they already gave you half your answer. They are telling you that the y in this system is equal to negative 3. That means we just have to find the x value. So if they're telling you y is negative 3, this is where the substitution comes in. This is why it's called substitution. If y is negative 3, then you go to the other equation up above there and you plug a negative 3 in right there. And now, the variable that we see that needs to be solved for, that wants to be alone, is x. How do you get x to be alone? Well, you got to get rid of that 10, so you're going to add 10 to both sides. A negative 3 and a positive 10 makes positive 7 equals 7x. X is still not alone. He wants to be alone. He doesn't want to be multiplied by 7. So you come along and you say, fine, I'll divide by 7 on both sides. That cancels. 7 divided by 7 is 1. Now we know that the x value is 1 and the y value is negative 3. That is the solution. Guess what, kids? If you were graphing these two lines on the coordinate plane, guess what would happen? Where x is 1 and y is negative 3, that's where your lines would cross. Somewhere down there. Yeah, pretty cool, huh? Let's keep going. This is one that's going to require a little bit extra work. Here we go. Here's what they tell you. Y equals 5x and y equals 2x minus 15. All right, well, if y equals 5x, what you're going to do is you're going to take a 5x, this little piece right here, and you're going to put it down there where the y is. It's called substitution. You substitute the value of one variable into the other equation. So now when I rewrite this bottom equation, instead of putting that y, I'm going to put that 5x there. Did you see what I did? I took this 5x and I substituted it in here for the y. Okay, oh, well, now look at this. I've got x's on the right and x's on the left. I got to get those x terms together. Do you remember who has to move in this case and who can't move in this case? I hope you remember that the 5x has to stay put. That means you have to bring that 2x term over to the left. And right now it's a plus 2x. So you minus 2x or subtract 2x. So those cancel. 5x's, take away 2x's, leaves you with 3x's. Okay? See what I said? This is what I mean. If you're a little rusty on your equations work, you're going to have to dig deep. We're going to spend a few days on this, so don't get too freaked out if you're feeling a little nervous about some of this math. It's been a while. Okay, now here we go. We're not quite done. X is grumpy. He doesn't want to be multiplied by 3. So you divide by 3, right? That cancels those 3's. Negative 15 divided by 3 is negative 5. Well, that's half of the answer. Now you know for your ordered pair, X is negative 5. Question is, what's the Y? We don't know. We have to go back to our equations. So now you're going to take your value for X, which we just figured out was negative 5, and we're going to go back up here, and we're going to plug it in. You can pick either equation. I would pick the smaller one. I'm going to choose this one. And right here, instead of X, I'm going to substitute in that negative 5. So it's going to say Y equals 5 times negative 5. Y equals negative 25. So there you go. There's the other half of your ordered pair. There's the other half of your answer. Isn't it weird how you can take information from one equation, substitute it into the other equation in the system, solve for a variable, then you take the value of that variable, go back and plug it back into one of the original equations to solve for the other variable. It's like a circle, like in my mind, I just see this like a circle, like a cycle. Like around and around and around we go until eventually we know what both variables are equal to. How many more do we have? I think I've got 2 more to do. Yep, 2 more. Here we go again. We're going to solve using substitution. So I look at my 2 equations. Obviously, this guy is going to be easier to work with. It's telling me that 4x is equal to 16. So you could just do a quick little work here with this bottom equation and you would know what x was equal to. So we could solve this bottom one by dividing by 4. Uh-oh, my calibration is off. Divide by 4 on both sides. That'll tell you that x is equal to 4. That's half your answer right there. Now you already know half of your answer. You know your x value. We're going to try to figure out the y value. Right? So that step 1 there was pretty easy. Step 2 says take that value and plug it into the other equation. So right here, I know what x is now. It's 4. So I'm going to put a 4 there. 7 times 4 plus 4y equals 24. Here we go. Let's do this math. We're going to solve for y. 7 times 4 is 28. Trying to solve for y. Y wants to be alone, so I'm going to subtract 28. Hey guys, 24 minus 28 is negative 4, by the way. Y still wants to be alone, so next step is to divide by 4. So that cancels. Holy cow, that was a lot of work. Y says thank you. Negative 4 divided by 4 is negative 1. So again, all I did there was algebra. I mean, we have solved equations like this. It's just been a while. So now we know that x is 4 and y is negative 1. And if you were to take those values and plug them back into either one of those equations mathematically, it would work. It would work. How about one more? Yay, Glessner says, do one more. All right, here we go. Solve using substitution. There's a nice little system. I like this bottom equation. He's nice and small here. I think I could solve that one for y pretty easily. So what would you do to solve for y? I would divide by 3 on both sides, and that would tell me then that y is 2. All right, that's half your answer. We know that y is 2, and now we're going to figure out what x is. So I'm going to erase all that. Go back to my other equation. You see where the y is? Right here. 9 times y is now going to be 9 times 2. So 6x plus 9 times 2 equals negative 24. See where that 18 came from, I hope. Right? 9 times 2 is 18. X says, I don't want all those numbers on my side of the equation. And you say, no problem. I'm going to move that 18 away using subtraction. That creates a negative 42 on the other side. Negative 24 minus 18 is negative 42. X is still not happy. He doesn't want to be multiplied by 6, so you can do the opposite and divide by 6, which cancels there. And negative 42 divided by 6 is negative 7, kiddos. We have the other half of our answer. X is negative 7, and y is positive 2, which, believe it or not, if you were to take a negative 7 and put it here, and a positive 2 and put it here, and do the math, it would work. It would actually work. Who misses graphing? That's just it, right? So we do something until you get super, super, super good at it, and then we shift gears and we send you in a different direction. So we're going to be working on these problems during class. Of course, I'll be there to grade your papers and check and help you and guide you as we go. This isn't going to be a one and done. We'll spend quite a few days doing this, okay? So hang in there. I'll see you in class. Thanks for watching.